Eurocode 2 is the new standard for the design of concrete structures. It's been hailed as a robust and rigorous design code, taking a less prescriptive approach to design. It's divided into 4 parts, covering general rules and rules for buildings, structural fire design, bridges, and liquid retaining and containment structures. Today we're concentrating on building structures and the first 2 parts. Eurocode 2 is of course to be used with other Eurocodes, such as Eurocode Basis of Structural Design and Eurocode 1 Actions on Structures, and other European standards relating to the specification of concrete, reinforcing steels and precast concrete. In this programme we're going to give you an introduction to Eurocode 2, the differences with the British standards. It's not just BS 8110 that has been withdrawn, and what you need to know before getting started.
And joining us in the studio to help us is Charles Goodchild from the Concrete Centre. Many thanks for joining us. Thank you for coming into the studio.
My
Charles
pleasure.
is co-author of this publication, Concise Eurocode 2. Charles, presumably you'd go along with that statement, robust, rigorous and prescriptive.
Yes, I think it is. It's all embracing, but rather than dealing with elements that we've been used to over all these years, it starts talking in terms of phenomena. So it talks about flexure, axial load and shear, rather than design of beams, columns, and so on.
And the old distinctions that we had between bridges and other structures,
That's
completely gone.
Well, there are a few extra bits and pieces for things like bridges and water retaining structures, but they work by exception rather than actually being a standard on their own.
So do you think it would be fair to describe the Eurocodes and Eurocode 2 in general as same principles but different rules?
Yeah, very much so, Martin, very much so. The only notable exception is variable strut theory, which is fairly new to us designers, but it's a basic principle that we can all understand.
And we'll come to variable strut theory later on in the
will.
programme. What would you say to those who would assert that to design even the simplest structure, you need to have at least 4 documents open? Eurocode 2 itself, the head Eurocode BSEN 1990, and the annexes for the 2 documents.
Yeah.
Is that a difficulty, do you think?
I think the volume of papers, volumes of publications you need is great. You need all those standards that you've mentioned. You need the head code, you need the basis design, the actions, you need the Eurocode 2 itself, the national annex, at least initially. But there are other documents. There's things like the national annex you mentioned for each part. There's things that we published, like the published document, which gives explanations. There's textbooks, background documents, guidance, and all sorts of things. But eventually, people will understand what they're doing, and they'll just need less and less and less material. And
So
it should
there's
be
a
easy.
few documents, but as familiarity increases...
As familiarity
things get easier.
increases, it'll make it a lot easier, yeah.
What would you say about Eurocode English? Because there's a different sort of language here, isn't it? And I've written down a few examples here, but you need to understand the different terminology.
Yes, there is. We have this term called Eurospeak. It's sort of English, but not as you know it. Jim. We know it. Yes, we talk about actions rather than loads. We talk about verification rather than checking, but it's essentially the same thing. When you look at it, it is actually technically very correct. It's just not what we as English native speakers would say.
So it's just a question. I've written a few down here, as I say. Eurocode 2 has an annex, you know, instead of an appendix. Instead of resisting forces, the structure sustains them. Instead of buildings being constructed, they are executed.
That's right.
But that's just a familiarity exercise.
It is a familiarity exercise, but even something like execution is technically the right term.
Just not what we're used to.
Not just what we're used to.
OK, let's have a look at the 4 parts of Eurocode 2.
Part 1.1, General Rules, is the principal part which is referenced by the other 3 parts. For the designer, there are a number of differences between Eurocode 2 and BS 8110 that might make things seem unfamiliar. For example, Eurocode 2 is laid out to give advice on the basis of phenomena, such as bending and shear, rather than member types. Part 1.2, Structural Fire Design, gives advice on fire resistance, referring to tables for minimum cover and dimensions for various elements, and gives methods for fire design. Part 2 applies the general rules given in Part 1.1 to the design of concrete bridges. It works by exception to Part 1.1. For instance, there are additional clauses on analysis and shear. And Part 3 does the same for liquid retaining structures, notably for crack widths.
Charles, what difference does it make laying things out according to phenomena rather than the old way that BS 8110 did it, according to member types?
I think, you know, as I said before, it's all embracing. The idea is that engineers actually do some engineering rather than just following the formula to make something work.
So rather than just looking up in the tables, you actually have to think a bit.
That you do. Or that's the intention, at least. It may not be so good for ordinary structures, let's say ordinary structures that, you know, day to day, but for all structures, you have to start thinking about what you're doing.
And there's little things like Eurocode 2 doesn't provide derived formulae. For example, you have to look those up elsewhere.
You do. I mean, that's the job for people like ourselves or the institutions to derive those formula and make people aware of where they come from and how to use them.
There's something else that I thought was noteworthy. It's only applicable for a ribbed reinforcement of strengths between 400 and 600 megapascals.
Yes, yeah. The reasons for that are that mild steel these days is more expensive than high-yield steel. There's no advantages in its use. But there again, we have made provision within the published document for those people that do use mild steel, say overseas, gives the rules that they can apply in using Eurocode 2 with mild steel.
Just highlighting some of the other differences, designs based on cylinder strength. That's a difference, isn't it?
It is, yes. I mean, that's just a European compromise, really, that everybody could agree to.
Units are megapascals rather
they
than units
are
per
indeed
millimetre squared.
moving into the 21st century. Yes, yeah.
I thought this was important. Eurocode 2 uses a comma, or all Eurocodes use a comma instead of a decimal point. What about that?
It is, but I think that's one thing where the Brits are sort of staying put. We all use a decimal point in the UK, and I think there's aspects of perhaps getting things wrong by a magnitude of 1,000, which would be rather inconvenient. And the other thing that's keeping us where we are is of course, computer programmes, where they all tend to use the decimal point.
Of course. Moving on to part 1.2, fire engineering.
Yeah. Well, part 1.2 gives you 3 methods of fire engineering, but it also gives you the basic tables that you use day to day to look up minimum member sizes and minimum axis distances, what they call, rather than cover, its axis distance to the middle of the reinforcement. You then have fire engineering methods, which, well, we can go into, but they're essentially a simple method. There's an isotherm method and a 500-degree method. But they're quite simple.
But there's more detail there.
There's certainly more detail.
OK, that's our introduction to Eurocode 2 complete. Let's have a think about what the designer needs to do to get started.
The first thing that the designer needs to do is determine the design life. These are given in Eurocode Basis of Structural Design and its national annex in order to establish durability requirements. Then assess the actions. A wide variety of actions are given in BSEN 1991, including densities and self-weights of materials. Next, determine which combination of actions apply, namely the value of actions when a limit state is under the influence of different actions. Numerical values for the partial factors are found in BSEN 1990. Then determine loading arrangements where appropriate. In other words, the arranging of variable actions to give the most onerous forces in a member or the entire structure. These are given in Eurocode 2 and its UK annex. Next for the designer is determine material properties, assessing durability requirements, concrete strengths, cover requirements for fire resistance and bond requirements, and so on. And finally, analyse the structure, determining the distribution of internal forces and moments so that the critical design conditions can be identified.
OK, Charles, that first step should be simple, determining the design life. They're all laid out in BSEN 1990.
They are, it's true, but you have to revert to the National Annex for 1990, and then there's a table, NA 2.1, which actually tells you things like design life, and for buildings it's 50 years, and for bridges, etc., it's 120 years.
But having to refer to a different document, that is a new concept.
That is a new concept, but it gives you the overall architecture of how the Eurocode is set up, so that every material is based on the same basis of design and the same actions.
Do you think that's a good thing, by the way, having it all contained in the key head Eurocode?
I think so. It gives you an overall architecture, as I say, to the whole of structural engineering, so that we in concrete are designing to the same rules as competitive materials.
Now, regarding actions, Eurocode 1 helps us here. Again, things are quite simple.
They are indeed, yes. All the actions are laid out in Eurocode 1, but again, we have a national annex to determine what they actually are in the UK. In 1990, Eurocode 0 actually lays out how we apply those actions in terms of patterns and little partial factors depending on where those actions occur or how they occur.
But loading arrangements, things are a bit different
They certainly are, yes. I mean, according to Eurocode 0, you've got to take every eventuality into account. But having said that, our Eurocode 2, the concrete standard, actually limits those within the National Annex to what we were used to. So for beams, etc., we have alternate or all spans loaded, as we did, and certain slabs we can just use the full load.
What about serviceability limit states?
Yes, we have to get used to looking at different serviceability limit states, and depending on what limit state we're looking at, for instance, cracking or deformation, might mean that we have to look at things called the combination or characteristic value of the variable actions. If we're looking at long-term actions, we might need to be looking at what's called quasi-permanent values of those actions. So it all gets rather complicated, but it's all horribly logical, I'm afraid to say.
And what would you say about material properties? Up to what class of concrete can be designed using Eurocode 2? And what would you say about reinforcement?
Right, OK. Well, essentially, we can get up to 105 megapascals cube strength. That's a C90-105 concrete, which is high strength, or getting towards the higher ends. But beyond C50-60, so beyond a 50-cylinder strength, you get little rules in there to stop things happening like brittle fracture. With respect to reinforcement, we have 3 grades, A, B and C. They're regulated depending on their ductility. You'd be using grade C for seismic regions, grades B and C if you're using plastic methods or redistributing by more than 20%. And grade A is the general grade that everybody uses.
OK, structural analysis, regardless of what method you use, what are the principles that apply?
It's the same as ever. You're trying to find out, you're trying to determine the member forces, what's happening internally, deformations, that kind of thing. So it's the same principles that plane sections remain plane.
OK, we're now in a position to design for flexure, check deflection, shear capacity, slenderness for columns, etc. Let's run through some of the basics of design.
Let's consider a section of a nominal beam and look at the strain and stress diagrams in the usual way. The strain distribution shows strains of epsilon C and epsilon S, and the stress diagram forces of FSC for compression and FST for tension, and a compression block of dimensions eta FCD and lambda X, and so on. For shear, here we see the mechanics of how 90% of beams would be designed for shear, using something of a new concept called variable strut theory. And finally, for columns, we see the total design moment for a column from M to M02.
OK, Charles, starting with flexure, I don't see too much different there.
I think you're right. It's virtually the same. There's a few variations in a few of the numbers, but otherwise it's what we're used to in the old British codes.
So is there anything you would highlight for the designer here to watch out for?
In terms of flexure, not really, no.
Moving on to shear, what is variable strut theory and when would it be applicable?
Well, it's applicable all the time, but shear forces in beams have been likened to the to the flow of forces as an arch. So as you get closer to the support, the angle of the compressive force gets steeper, and so it gets steeper with more load, more shear load, and that's what really the variable strut theory. But the standard actually limits the angle in which that strut can happen, so between 21.8 degrees and 45 degrees. And what will happen most usually in most beams, which are not that highly stressed, we'll be looking at the 21.8 degrees, which gives us a cot theta of 2.5, which everybody will get to know as 2.5, and it'll become the way that we design all beams, I'm sure. And that's the 90%.
And where should you look for more information if you need it?
I think in guidance documents.
OK.
It'll be quite difficult actually in the code itself.
OK, to look in concise Eurocode 2 or similar.
Absolutely.
OK, and for columns, what does the designer need to know here? When is the column slender, for example?
Right, well, he's got to consider quite a few things. Firstly, he's got to get the analysis right and get the elastic moments in the column. That's first-order moments. He's got to think of then, in terms of imperfection moments, that's dealt with as an eccentricity. And then you come down to slenderness and slenderness is defined as effective length divided by radius of gyration, and that has to be compared against this entity, which is 20 ABC over root n, which again everybody will get to know. A and B are fairly simple and fairly standard, and there's default values of that. This entity C is quite important, and that depends on the shape of the bending moment diagram through the column. So typically, when you've got double curvature, it'll be 2.7. If it's uniform moment, it'll be 0.7. So that makes quite a difference. And root n is the root of the axial stress in the column. But generally, there'll be fewer slender columns, so generally it shouldn't be so much of a problem.
So in general terms, it's only really the variable strut theory that the designer needs to get his head around that's new.
I think it's finding these things as well. I mean, finding things like how to deal with slenderness is actually quite complicated within the code, but that's when you look towards the guidance documents to help you through.
OK, now where to find more information? There's a website to Eurocode 2, eurocode2.info.
Absolutely. Of course, we as the Concrete Centre provide a lot of information. We help to run the eurocode2.info website, and there's plenty of other information from textbooks, institutions and so on and so forth.
If you use your concise Eurocode 2 publication, are you designing in accordance with Eurocode 2 without actually referring back to the original standard?
Absolutely, absolutely. The intention of the Eurocode, concise Eurocode 2 is that if you're dealing, say, with shear and are slightly wondering what you should be doing here, you can actually look up the clauses because we give reference to the relevant clauses in there.
How do you see things panning out and Eurocode 2 developing?
Eurocode 2 will take over the world. That'll be it'll be the only way we design concrete structures, certainly in the UK. And certainly if there's anything to do with a European notion to the work or any cross-border activity, then Eurocode 2 is the way to go. And indeed, you can see it now with some of the large projects going towards the Eurocodes.
What feedback are you getting at the moment, for example?
Variable. I think people see there's a whole lot of information to take in. It is, you know, where do we get this information? Where is it? But there is a way through, and people are finding their way through quite simply.
Well, I'm afraid, Charles, we're out of time. Many thanks for coming into the studio and guiding us around Eurocode 2.
My pleasure.
Don't forget to take a look at the other programmes in this series and the study notes that accompany this programme. However, for now, from us all in the studio, goodbye.